So, it's been a few weeks since I cut these out on the plasma, the engine mounts. So today I'm going to run through drilling the holes in them, but also run through how to sharpen a drill bit, as in the past I've known people to throw these out when they're blunt. So got my grinder, little bench grinder, and yes, so I might start with the drill sharpening first, and then we'll drill the holes, mark them out, drill the holes in the engine mount plates. Okay, so ignore the mess on the bench. Basically, yeah, everyday high speed steel drill bit. So this is new, so it's quite, yeah, hasn't been used, I don't think, at all. Maybe once. So it's the right angles and everything's pretty much good to go. So what we'll do, what I might do just quickly, which is what my trading did when I was in my first year, grab a drill bit, so now it's stuck. I just want to go through some angles, so we'll get to that bit in a minute. So if you've got yourself one of these books, which I got in my first year as an apprentice, in the back you get one of these, which has all your angles on it. So 60, 118 is what your drill should be. So the idea of that is you stick that in there, and because I just racked it on the grinder, it's not 118 degrees. So the idea of that is you sharpen your drill bit and it should be that angle. Now, have a bit of a laugh. This is the one I made, I think it was like my first year. There actually isn't a 118, but there's a 121, which is close enough. So with these angles, 118, yeah, 118, give or take a few degrees, and it's still going to work. So yeah, that's my first year TAFE job. I think it was first year. Anyway, we won't use that one. Okay, so on your drill, let me find something to point. You've got your two cutting edges, which is across that front, across this front edge. So there and there. And then this angle down the back here is what you call your relief. So when we sharpen it, we want to get the angle on the grinder right, but you also want relief. So a lot of people, I'll turn this camera around and work on the grinder, and I'll show you what I'm talking about. So hopefully this will work for you guys. So I've marked a little texture line here, just to give me an idea of what my angle is. So we want, so 118, let's just call it 120 for ease of maths. So you want 60. So I've actually, that's your 60 degree angle there. I've stuck that there like that and marked my 60 degrees. So that'll give you a guide of where you want your grinder, where you want your drill bit lining up with the grinder. Now I don't have a dressing stone for this, so hopefully it works. So the idea is, I use my finger. I've seen people come that way. I've also seen people, I got taught that way, so that's the way I'm going to do it. So my angle, that way, and I'm looking along that edge. So you want to touch and give it a little bit there. So the idea is you want your cutting edge then the relief needs to be away, pulling back. It's like 7 degrees or something like that, but yeah, as long as it's got relief. So if you're here and you're doing that, try and keep it there and spin it in your fingers so your angles are still pretty similar. I gave this a good workout at the beginning so it's not happening too quick. So once you get your closer back to where you want it after manipulating it at the beginning there. So I don't think this will happen. Cutting edge, and then relief. Take a relief thing, this edge over the back. So what happens is, if you're drawing a hole, and the relief at the back here, probably needs to take a little bit off that. Lift the back is hiding the cutting edge, that will rub, and you'll end up heating it up, hardening your drill bit, and hardening your workpiece. I really gave that a workout at the beginning, but that's not looking too bad. That edge is still a bit overdone. Yeah, so that's better. So, and then you just kind of want that edge and that edge to be the same width. Yes, alright. So that's that. Now we're actually going to draw a hole with this. So my next one, so pilot holes. So that there's your web. Okay, so this little bit across the top here is called the web. So your pilot hole that you drill is generally to give you clearance for that web. So I can measure it. It's like 3 mil. So you'd need to be drilling a 3 mil pilot hole for this to give that clearance. So got our drill bit done. So marking holes. It's still going to work. So anyway, because I've used that as my datum, this edge, this hole needs to be measured from this edge, or hole centers. So we know, so if you go, easiest way to do a hole, instead of trying to get the center to center, just go from one edge to the other edge, which is 45 mil, and then we transfer that to that, which I've already done. I don't know if you can see the pencil line on there. Anyway, so 15 mil and then 45 mil. So there's those two. I got my center punch, got the hammer. Alright, 2 holes center punched. Alright, so my next one, measure this hole. It's about 13 mil, which is what this is. 13 mil drill bit. Alright, so we're going to go over here now. Alright, so I'm just going to line it up. Just give that a little spin. So if you don't have, it's a whole different way people can set zeros up with stops on here, stuff like that. Okay, the next thing I wanted to talk about, just let me hold that, let me get back to the whiteboard. So drill speeds. So the formula I learnt was 300 V over D. That's all you need to remember. So 300, I don't know where they got that. I don't know where they got that number from. V is your velocity of the material you're drilling through. So mild steel is generally 30. So we're going to go 300 times 30 divided by D being the diameter of your drill bit. So we're going to call it 13. I'm going to need a calculator because I'm not that clever. $300 times 30 divided by 13. So we're looking at 690. 690 RPM. So that's what your drill bit needs to be for mild steel. So your harder steels like your stainlesses, you're probably looking at 20 for your velocity. And then your softer ones like aluminium and things like that, you'd probably go a bit higher, maybe 40. Now, this is on a drill bit. Oh, sorry. This is on a drill. If you're doing a lathe, the diameter becomes the diameter of the job, not the drill bit. So on a lathe, your drill bit's stationary, and you spin your job. So that's basically how you convert that. So if it's a 100mm job, that's 100. Yeah, cool. So let's do that on this machine. So here's your speeds and feeds here. Make that a bit clearer. So that was 690. We've got a 700. That's about our 700. The next one down is 500. So we're going to go 700. So I've already checked the belt in here. So this thing is a belt. Let me just show you this because it's, get the torch up then. Still have, anyway, so it's belt driven. So basically you've got to undo this, pull this handle to loosen the belt, and then adjust the belt to what you need. So when you look at the front here, it's telling you where the belt needs to be. So for 700 it needs to be on C and F. So if we go around here, so that's second one from the bottom on this side and the middle on that side. So if we come around here, second from the bottom and that one's the middle. So that should be good to go. Let me put that all back together and I'll come back to drilling. Alright, so here's the test. Will it drill? So there's a thing called pecking. So go down a bit and then lift. The idea of that, if you're using coolant, or if you've got yourself like a cutting compound, as you pack, coolant enters that spot, or you spray some of this in there. It helps cool the job, cool your drill bit. And it also, you've got a long swarf coming off it that breaks that swarf, so you don't end up wearing it. See how that swarf is pretty long? If I lift it, that breaks it. Alright, that's the first hole. Okay. Alright, that's about it. I'm going to, I'll mark the rest of these out. I'll mark the rest of these out later. Cool, anyway, so that's those two done. I've still got a few more to do and then that plate. So I'm basically just going to do that on my own. You just don't need to see all that. And then, yes, the next one will be back up at the shed where the buggy is, and I'll bolt these on, and then I don't even know where those other bits went. Anyway, bolt these on where they need to go, and then it's lining up the engine and working out the tabs that get welded onto this. Cool, alright, catch you later.